Okay, so we hear it all the time, right? The most powerful AI models are getting ridiculously smart. They can write code, they analyze complex data, they can even create art. But can they actually understand the physical world we all live in? Well, that's the billion token question we're investigating today. And the answer reveals a pretty surprising blind spot right at the heart of artificial intelligence.
All right, check this out, because it's a real paradox. On one hand, you've got these top AI models that can just crush these super complex abstract problems, the kind of sophisticated pattern matching puzzles that would make most of our brains hurt. They're basically superhuman in these areas, seeing connections that we would totally miss.
But then you turn around and give it a task that seems like child's play. Like, hey, what's the top-down view of this simple 3D object? It's something a kid could answer in a second, almost without thinking. And yet, the world's most powerful AI can get it completely wrong. How is that even possible? This is the paradox we're exploring.
And that failure points to this huge and honestly often overlooked dimension of what it means to be intelligent. It's not about knowing facts or recognizing patterns in a spreadsheet. It's about fundamentally understanding the physical world. And this right here is AI's surprising blind spot: spatial intelligence.
So what exactly is this skill? The one we take for granted every single day, but that the most advanced AI really struggles with? Let's break it down. Spatial intelligence is that intuitive knack, that gut feeling for navigating and manipulating the three-dimensional world. Seriously, think about it. Every time you assemble IKEA furniture from a 2D diagram, or play a game of Tetris with your suitcase to make everything fit, or even just try to parallel park your car, you are performing an incredibly complex spatial reasoning task. It's absolutely fundamental to how we interact with everything around us.
So to figure out if an AI actually has this skill, you can't just ask it. You have to test it. And researchers have designed a very specific and very tough set of challenges to do just that.
To really measure this skill, researchers created what you can only call a gauntlet of 6 fundamental capabilities. Think of it like an obstacle course for the AI's mind, one designed to push its understanding of physical space to the absolute limit. And this gauntlet covers the whole shebang. It starts with simply judging size and distance, but then it ramps up to mentally reconstructing a 3D object from flat blueprints. It tests if the AI can understand where objects are in relation to each other, or if it can see a scene from a different viewpoint. And then come the really tough ones, mentally folding paper into a box or building with blocks. And finally, using all these skills together to solve complex puzzles.
So, with the test all set up, it was time for the main event, putting the latest generation of AI through its paces against this gauntlet.
And let's be clear, this was no small pop quiz. We are talking about a massive evaluation using tens of thousands of unique questions at a cost of over 1 billion tokens. The scale is just immense. For example, you have benchmarks like SIGHT and MindCube that were designed to rigorously test very specific skills, from reasoning across different views of an object to mentally rotating it in 3D space. After running this massive trial, the results are in. And, well, it's a classic case of good news and bad news. The good news is a knockout. The latest top-tier model has set a new state-of-the-art in spatial intelligence. It surpasses all other models out there, both proprietary and open source, by a really convincing margin. It is a huge leap forward. For example, on a tough benchmark like SIGHT, which focuses on that multi-view reasoning, the top model scores over 64. That is a significant jump ahead of its closest competitors, like Google's Gemini and other powerful models. There's no question, it's the new champion on the block.
But here comes the bad news, the real kicker. While this AI may be the best of its kind, it is still nowhere near as good as the average human, not even in the same ballpark.
The performance gap is just stark. On benchmarks where the top AI is scoring in the mid-60s, humans are scoring in the high 90s. This isn't a small gap that can be closed with a little more training data. This is a fundamental difference in ability. It really just shows how intuitive and powerful our own spatial intelligence is. So where exactly is it failing? Well, the research shows the biggest struggles are in those really tough categories we saw earlier. Tasks that need you to mentally fold and assemble something, take another person's perspective, or reconstruct an object in your mind, these are still profound challenges for AI. Let's make this tangible. Here's a classic spatial test. You have a flat 2D shape. Can the AI mentally fold it into a 3D cube and recognize what it would look like? The answer is a simple and resounding no. It fails. and it picks an impossible configuration. This just highlights its limitation in reasoning about anything beyond rigid shapes. Okay, how about another one? A simple counting task. How many blocks are in this image, including the ones hidden from view that have to be there supporting the others?
And again, nope. It can count the blocks it sees, but it fails to infer the presence of the hidden ones. It lacks that basic, common-sense physics that tells us the top blocks have to be resting on something.
These failures aren't just trivia, you know? They point to what might be the next great frontier in the quest for true artificial general intelligence. So, what have we learned here? Well, while the newest AI models are a massive step forward, there is still a significant gap to human ability. We see that the toughest hurdles are those intuitive skills, like mentally folding objects or visualizing different viewpoints. And that leads to a big conclusion. Mastering the physical world is one of the final and maybe the hardest frontiers for AI.
And that brings us to why this matters so much. As the researchers themselves conclude, without this skill, you can't have truly useful robots or agents that operate in our world. An AI that can't understand physical space is an AI that's trapped inside the computer. Which leaves us with a final, pretty provocative thought. We've seen the incredible things AIs can do now that they've mastered the world of language and data. So, what happens when they finally master our physical world? What happens when the smartest minds are no longer confined to just a screen?